This. You guys are correct in your thought. You were supposed to have a quiz tomorrow, but I have made an executive decision.
No more quizzes, bro. I'll take it out.
That would be very nice for some.
Did I die? That's the only chance of that happening. I'm going to move your quiz.
Oh, Jesus.
I'm going to move your quiz to Thursday.
Thank you, Jesus, Lord.
The reason I'm going to do Thursday is Friday you won't have school because apparently I'm going to some training.
Well,
I didn't know about
that's
this.
hard.
So we don't have school Friday.
I'm sorry,
No. Teachers will be going to some fancy, nice training, which will probably end up with a third of our staff actually going to the training and everyone else doing what y'all would probably do if we had school, skip out. So, your quiz will be Thursday. That gives us time to practice these really good, practice these problems real good, and for me to finish up topics and get us to the point to where when we come back, we can hit bonds. It'll be a beautiful thing. So that's good news for you all, though, which means you all will have an extra quiz, but it will be the easiest quiz you will ever have in this class.
When?
So one quiz I will not give you a periodic table for because it will be your element quiz.
Define elements, like all of them?
I choose like 50,
Oh, okay.
the most common ones. You don't need to know them all. There's some on there that honestly I don't know. Why? Because you just never deal with them. I know, that's like shocking. Like, how are you?
Like Samer,
A chemistry teacher, I don't know all 118 elements. So, for today, I want to cover the idea of this. So, there's something you can do with the periodic table.
Yeah, I have an element. Bring up the day of the element. Oh, no.
Promise you? Simple. So if I actually give you the four quantum numbers 4, and I can give you an element per se. So do uranium. That was pretty hard. So whenever you do this, you practically set it up. Principal quantum number N, angular momentum quantum number L, magnetic quantum number M sub L, and the spin quantum number. Now, you don't know how to do this, but I want to show you how fast this can happen. After I do this, what I'm going to do is that periodic table I gave you, I'm going to show you how to break the periodic table down for this to happen for you. It will be automatic. So, this is one of those things you can learn how to break the periodic table down. You get the periodic table on Thursday, break the periodic table down, and you've got it set up for you. So here's the thing. Look at uranium. This is the first thing I like to do. Uranium. So I look there. Uranium is in the F block, which means I'm going to start with L. Because L is for S, 0. P, 1. For D, it's 2. For F, it's 3. Which means L for uranium is 3. I'm going to show you how to break it down in a little bit. From there, I then look and see what's the energy level. That energy level is just like when you was doing the orbital notations. Go through, I'm in the 7th row, but I'm in the F block. So if I want to find N for F block, N equals rho minus 2. So 7 minus 2 is 5. So, M sub L, you liar.
That's what I was going to say. You lie so much.
M sub L is those orientations, and this is where you got to see the periodic table broke down to make sense for you. So, M sub L is 0, and same thing for the spin quantum number. It's in the first half, so plus 1/2.
What's the second half?
It's negative. So there are the 4 quantum numbers for uranium. Now, I bring your attention to the periodic table. The gift that keeps giving back to you. Whenever you do chemistry, you always have the periodic table, yes?
Almost, yeah.
So here's how you got to look at it. Everything's going to revolve around, when you're breaking this down, angular momentum quantum number L, and what block you're in. So this is the way to look at it. What block is this?
S.
So if it's S, L is
1.
0.
Okay.
Since L is 0, you then think about the possible ranges. So the possible ranges, if L is 0, what can M sub L be? It's from negative L to positive L, right? So M sub L is what?
Negative 0 to 0.
So just 0. This is where this comes into play. M sub L are your columns. Does it make more sense when we get out of the S block? Just accept it for now. So, this is column 0 and 0. What you're going to do is you'll run through your orientation one time, then you'll go back through it a second time, and you break them in half. So, how many columns is in the S block? 2. Here's the half point, right? Split it in half. Guess what this column is? Plus 1/2. This column is negative 1/2. And you guys already know energy level for the S block, N equals rho. So,
Film chemistry.
you're not going to fail. You'll get this. Promise. So, someone choose me an element. Give me an atomic number for one of the elements here in the S block.
1.
Okay. Hydrogen. So, atomic number 1. Let's do the 4 quantum numbers. So, we have N, L, M sub L, and M sub S. So we're looking at hydrogen, right? Hydrogen's in the S block, which means L has to be
0.
0. How do I know it's 0? Because it's the S block. So whenever you're looking at L, what block is it in?
0.
So then let's go to N. So, energy level. We know that for the S block, N is equal to the row. So what row is hydrogen in?
1.
The first row. So it's 1.
But I thought row minus 2.
What?
What's row minus 2?
That's F block.
Oh, I'm sorry.
M sub L. This is the column. Whenever you're doing this, look at your column. Hydrogen's in what column? What orientation? 0. Then you got to look, is it in the plus 1/2 or the negative 1/2? Plus 1/2. There you go.
So where did you get 0 on the N sub L?
Do what?
Where did you get the 0 on the N sub L?
Because of the range, you break the columns down. When we get to the P, it's going to make more sense. I promise you, because S is like one of those like, okay. That is the proper breakdown for the S block. Let's go into the P block. So, we are here in the P block. P block is columns 13 to 18. See? Okay. If you're in the P block, What's L got to be?
1.
He was number 1. So, L is 1. What does that mean? The possible range for M sub L.
Negative 1, 1.
Negative 1, 0, 1. Say it.
Negative 1, 0, 1.
Beautiful job, dog. Negative 1, 0, and 1.
It's almost like I already know it.
I know, right?
It's like his own voice is just telling me it.
How many columns is in the P block?
6.
6.
What?
13 through 18. You have 6 columns. So in this case, these 6 columns, how many orientations you got?
3.
And that's what you're going to see. Every one of these are going to have half. That's why you have the plus 1 half and the negative 1 half. You're halving it. So we'll half at 15 and 16. Now, go on and label your orientation. I do recommend you doing this Thursday. Whenever you take that quiz, I recommend you doing this. Just start at your first column. So we start the 13th column. This is negative 1. Then 0 is 14. 1 is 15. Look, you make it to the halfway point. Once you do that, just repeat. 16th column's negative 1. 17's 0. 18's 1. Why are we doing this? Why doesn't it go negative 1, 0, 0, 1, 1? Hund's rule. Each orbital of the same energy level will receive 1 electron before they receive the second. It's the same thing. This is why you run through the orientation, then you do it again. Now break it down some more. Look here at the first part. The negative 1 to 1. The first set of the orientation. These columns is the first half, so it's what?
Positive.
Plus 1 half. Bless you. Bless you. You're welcome. Look at the second part of your orientation. What is that?
Minus 1 half.
-1 half. Now, for the fun of it, remember, you got L, you got M sub A, you got M sub S. For P block, N equals what? The row.
Row.
Thank you. Row, row, row your boat. Okay. Somebody give me an atomic number.
12.
For something in the P block.
16.
16, thank you. 12 is magnesium, it's in the S block. Thank you. So, we're going to look here at sulfur. So, let's get 4 quantum numbers for sulfur.
This is so hard.
Alright, so, first things first, you're in a P block. If you're in a P block, it means what for L?
1, 2,
It is 1.
1.
I bring your attention here. I labeled it on the board for everyone.
It's cold in here.
Oh my God.
I'm freezing to death. This lukewarm coffee is not helping.
Who drinks lukewarm coffee?
But it has 3 minutes, so it kind of got cold quick. So
Yeah, because you put something cold in it. Alright, so L is 1. What about N? What about the principal quantum number? What is that?
it's the row.
The row, so what is it?
16.
The row, not the column.
-1.
The rope.
Rhonda.
1, 2, 3, 4, 5, 6, 7.
It is true.
3, thank you.
You gotta take Rhonda Cole.
-6 on a good day.
Rhonda Cole failed you.
We're just going through and I just can't, I was having like the lid. 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 The lid.
Did we get an award now?
All right. All right. M sub L. How do you find M sub L? You broke the columns down. Look at your element. What column is it in? The -1.
I have a question. Where'd you get 1 for L at?
That is one of those you just have to know it. For L, let's do it here. For L, if you have the 4 blocks, S, P, D, and F. If it's S, it's 0. P is 1, D is 2, F is 3. It's a good question. Anybody else like, hey, I.
Oi!
I.
Oi. Oi.
You're welcome.
Does everybody get that, like where I'm getting L from? Because that's the thing, like you remember, if you go back when I gave you the principal quantum, when I gave you the 4 quantum numbers, I said that, I showed that to you and I said kids struggle with this. This is the one thing you just accept. We just labeled it. S is 0, P is 1, D is 2, F is 3. Okay? So, what about the spin quantum number? Is it +1/2 or -1/2?
-1/2.
Why -1/2?
It's in the second half.
It's in the second half. There are the 4 quantum numbers for sulfur. Wow, so fancy. Everybody good with P block?
Yeah, people
Okay.
Nobody else heard that.
So now where are you going, Mr. Hall?
We're going to go to the D block.
That one is your time?
Is number 12 in the D block?
No.
Well,
I don't want to do 12.
And I'm not trying to point fingers, but I'm a little confused.
I want to do
Number 12, right?
No, that.
Well, there's also
Not that number 12, the other number 12.
The 12th for up the column? Yeah, 12th columns, D block.
Oh, gracias por...
I want to do 76 now. 111.
Awesome.
I didn't want to do it and
Alright, so we're going to do D block. D block is columns 3 through 12. So 3 through 12. So whenever we're looking at D block, we're in the D block, so what does that mean L is?
2.
It's 2.
I thought you were going to have wrong. I said it right there.
Now I was pausing because I was hoping everybody else would get involved, but everybody's like so tired.
It's
I
so
haven't
cold
yet.
in here. It's like we're all frozen in the fall.
Stand up, do some jumping jacks. You'll thaw then.
My Muppet Talk shows I don't do jumping jacks. Yeah, I would.
Oh, how did you do it?
Alright, what's the range? M sub L if L is 2. -2, -1, 0, 1, 2. So, label the columns.
So basically, if you don't know, you can kind of see it, right? You just put it in half and see how far it goes, like a number line.
So, -2, -1, 0, 1, 2. Halfway point is between 7 and 8. So, repeat. -2, -1, 0, 1, 2. Now, here's the first. time we go through the orientation, which means that's plus 1/2. Second time is negative 1/2. See?
Is the right
No, it's
half
the D block.
always negative?
Yes, you always start with positive 1/2.
Mr. Hall, it's the D block, not the C block. We don't have one of those.
No comprende.
Not yet.
Okay, you're in the D block. What does that mean N is? N equals?
The row.
Minus
1.
Row minus 1.
Wait, why that?
Did you say so bottom?
Row minus 1. That's it. When you get in the D block, remember, you did those energy levels for your electron configurations. It's N equals row minus 1. Okay? So, you got N, got L, M sub L, S. Somebody give me an atomic number for something in D block.
76.
Yes.
It's already in there, I checked.
45.
76. Osmium.
How do you say that?
Osmium. So, let's do the 4 quantum numbers. So, N, L, M sub L, M sub S. Yay! Alright, so we're doing number 76. Here's set 76. So I look at it. What is L?
2.
How do you get 2? You just have to accept it's in the D block, so L is 2.
Because Mr. Hall said.
I hope that's on the test. Why? You just have to accept it. Just have to.
Why ask why when every day ends in Y? My dad tells me
Except
that.
for, wait, what about tomorrow?
Alright, so what about N? What's N?
-2.
5.
No. N equals row minus 1.
4.
So it is
5.
it's 5.
Well, I failed my
You just grab.
Look, 1, 2, 3, 4, 5, 6. Osmium's in the 6th row.
6 subtract 1 equals 5.
There we go. You would destroy the SAT.
No.
You're
Yay.
wrong. I'll show you my ACT.
What'd you get? They come back, what you get?
You know what?
You know what you got.
Alright. M sub L. What we got for M sub L?
-2.
-2. How you get -2?
Is it the -2?
Because it's in the -2 column. Columns are straight up and down. What about M sub S? -1/2. There are the 4 quantum numbers for osmium. Very nice, right?
Yeah.
I heard a 6.
This is what I'm saying with this. This is where if you break the periodic table down, you have it set for you.
Are we doing F?
Let's go to the F block. Okay.
I miss Mr. Evans.
Look at the F block. If we're in the F block, L is what?
3.
Today.
Oh.
Now, if L is 3, M sub L is what?
-3, -2, -1, 0, 1, 2, 3.
I get this now, Mr.
-3, -2, -1, 0, 1, 2, 3. I did it up there over top of the D block just so I had room to put it, because that's pretty long. So, label it out. We got -3, -2, -1, 0, 1, 2, 3. Halfway point. Between atomic number 63 and 64. Repeat the process. -3, -2, -1, 0, 1, 2, 3. So we look at it. The first time through the orientation is spin quantum number will be
Like, which
positive
number's
1/2.
big?
That's when you end
Oh.
up. What's 1/2?
Pay attention, darling. It's unacceptable. The second time through the orientation, the spin quantum number be what?
Negative 1/2.
Negative 1/2. I tell you what, I'm so proud. You destroyed SAT.
You won.
I would love to show you my ACT.
Now,
It's actually not that bad.
SAT very hard. ACT
N.
also very hard.
N for the F block is what? Row -2.
This is why I used to only want to go to good school.
Mr. Hall, you'd be proud of me on my science part. I got like a 22 on my science.
I'm so proud.
I got a
Y'all bring joy to my heart. You all are the reason I get up in the morning.
You're the reason I get up in the morning
That's
because I don't want to
kind of
fail.
creepy.
If we text you and we say we're not coming to school, you won't show up either.
Nah, I'm still coming.
Oh, see, then we're on the reason.
Yeah, he comes.
There's
to
more
our
than
science
just you.
class.
There's other students that need teaching. Other minds need homework.
Yeah.
Yeah, I come for the children.
He's not listening.
You all, I'm here for you, to inspire you, to become scientists and change the world and become doctors. So you know, if Mr. Hall comes in and needs a surgery, you'll be like, oh, Mr. Hall, I do this for free.
Be honest, do you really think you're going to let us operate on you?
Yeah, some of y'all would after you pass medical school.
Maybe a couple
you heard
of us.
that. You passed, you get to do surgery on Mr.
Oh, no, not him. Not after like the whole microwave stuff. We ain't doing that.
What microwave stuff? Have you looked into that program yet?
All right. Somebody give me an atomic number for something besides 92, because we already did.
98. 98.
64.
Californian.
We're doing 64.
California.
How do you say 98?
California.
They just run out names, didn't they?
No, actually, the cool thing of it is you actually, once those are synthesized, so they were created in a lab, and the reason that number 98 is called Californium is because of the researcher and the university he was at whenever he did the synthesis of a lot of these elements.
It's
Kinda like Beanium.
To help you, yes, 97 is named after the university that he worked at. It's research that he done to
Berkeley.
synthesize it was done at Berkeley University in California.
What about
You're working
Einstein?
right?
He named it Einsteinium because of Albert Einstein.
Well, I kind of figured that.
That's like a lot of people get caught up on wanting a Nobel Prize. If you can get an element named after you, you will have something more desired.
You know, Bill Gates has a big periodic table with each little element in it.
Alright, anyway, so that was your history fact for today. You're welcome. So, let's look at the four quantum numbers for atomic number 64. Gadolinium. Okay, what is L?
3.
How you get that?
You just have to accept it.
You have to accept it. I wrote it on the board. S is 0, P is 1, D is 2, 3, and F is 3. N. What is N?
Roll minus 2.
Roll minus 2, so what you get?
4.
Yes.
Wait, I don't know.
Which one was that?
What?
Here's the thing. Pay attention. I want all eyes on me, no talking. Very important. Remember why Mr. Hall uses this periodic table. Because of this right here.
Oh,
The lanthanides, which is this first F block, fit right there on the periodic table. Actinides fit right here on the periodic table. So they are actually part of the 6th and 7th row. Lanthanides is in the 6th row. Actinides is in the 7th row. This is not the 8th and 9th row. That's why I'm taking the time. All eyes are on me. There's no talking, so you're focused. Because you have to get that. I promise you, I'm going to give you an element from the F block to make sure you have that mastered. I'm telling you right now. It is coming. Okay?
Are we getting a worksheet?
Yes, you will. So, we're in the 6th row, so n equals rho minus 2. 6 minus 2 is 4. You would destroy the SAT. M sub L.
-3.
How you get -3?
It's in the negative column.
It's in the -3 column. Look at you. You would destroy the quiz on Thursday. -3. What about the spin quantum number?
-1. Negative .5.
-1/2. Why is everybody putting your stuff away?
Is it time to go?
It ain't time to go. We got 3 minutes. We got 2 minutes.
I have a question.
Yes, ask your question.
Are we going to do the worksheet in class tomorrow? Are we going to something?
I have more stuff to cover.
How much more do you want to cover?
A lot of stuff.
So much material. This carries a 4.3 in 80 dollars. Yeah, that's a lot. 3.5 pages long.
All right, listen, children. So this is a goal. My periodic table is not labeled. Your periodic table should be labeled. So if I looked at you and asked you for the 4 quantum numbers, for atomic number 18, argon. This is where we're going to try and get you.
L is 1.
Wow, I am zoomed out. So atomic number 18, argon, when you're looking at it, start with L. What's L?
1.
Why is it 1?
Mr. Hall said so.
Because it's in the P block. What is N?
Row.
How do you get N as 3?
It's in the 3rd row.
3rd row. And in P block, N is equal to the row. M sub L. Why do you get 1?
In the 1.
It's in the 1 column. Spin quantum number.
It's in the back half.
-1/2. There's the 4 quantum numbers for argon. This is where we're going to be looking. Now, tomorrow when you come in, I'll go ahead and tell you what we're going to do. We're going to reverse it. I'm going to give you the 4 quantum numbers. We're going to work back and find the element. Have a great, wonderful day. Destroy the rest of your classes.
3 is